Welcome to another unit in this workbook, Statistics. This time we're going to talk about the so-called chi-squared homogeneity test. The chi-squared homogeneity test is one of the group of chi-squared tests which are usually in one way or another concerned about distributions, underlying distributions. And that's, well, exactly what the homogeneity test does. It compares whether two samples, we call them m and n, of a certain variable have the same distribution p, follow the same distribution. That's actually the important part with this homogeneity test. Doesn't test whether they have comparable distributions, but tests whether they both follow a joint distribution. So there's only one distribution we're talking about and not two which we are comparing. Our null hypothesis, therefore, the two samples share the common or the same distribution p. Well, for this we're going to need a test statistic. The test statistic here is actually relatively straightforward. It's a classical chi-squared statistic. It's actual values, this one and that one, and then actual value minus expected value for sample n, expected value for sample m, the distance or the differences squared divided by the expected frequency of each of the two samples. As with all chi-squared tests, the question arises, how do we get these expected frequencies? Well, in this case, we are having to do a little bit of work because first off, we have to get the overall number of observations in each of the two samples, add them up to get the total number of observations. And then we're going to take those as the denominator and we're going to divide the sum for each group, which we are considering here. That's the ni plus mi. We're going to divide this by the overall number of observations. That's our underlying distribution p. This value for the distribution we're going to multiply with n for the expected values for n and with m for the expected values for m. So we first usually calculate this common distribution. Then we're going to multiply this with the overall share of our sum of n and m as a sample. Well, once we did this, we can also get our reference statistic. The reference statistic here, chi-squared I minus 1, 1 minus alpha, alpha the margin of error, and I the number of rows or different groups we are considering here. So I minus 1 is the degrees of freedom and 1 minus alpha is the margin of error. So if we look this value up in the table, we first have the 1 minus alpha that gives us the column and the degrees of freedom which gives us the row in which to look for. Well, that's then everything there is already to the homogeneity test, the chi-squared based homogeneity test. We could just add one final comment because, well, whether we do a homogeneity test or a test of stochastic independence regarding the final test statistic and the reference statistic, it will turn out exactly the same. So it's just a slightly different perspective we're going to take here, whether we're conducting a homogeneity test or whether we're going to conduct a test for stochastic independence. Well, with those concluding words, we're at the end of this session, which I hope you enjoyed. I say goodbye and see you next time.